All right. So, welcome. Good morning. My name is Dennis Bray, and I work for Enterprise Networking Solutions. It's probably the only time you'll ever hear it say it all the way out. ENS. I'm an architect, and I'm also a VMware instructor, and have had the good fortune to work on some pretty interesting projects around the state. And the session today, this software-defined networking, this real-world how-to, we're going to be concentrating on VMware and NSX. We'll start with basics. Hopefully, I'm certain, as I see the faces in here, you'll have seen some of these slides from VMware. Some of you, I'm going to guess 6, 8, 10 times. I'm assuming there's somebody that hasn't maybe seen it before. You got a question? We'll go through them quickly if that's the case. And then we'll go through sort of a little bit about sort of the product, the scope of what's there, talk about the considerations for deployment and design. And in the second half, we'll have more like a case study for the project that we've been working on at Department of Water Resources or the Resource Agency. And Chris Binger and Reza Naiman will help out at that point. They'll actually run the demo and ask questions. And as we go through here, if you've got questions, go ahead and bring them up. So as I already said, pretty much overview. A little blurb promised we would hit every layer of the software-defined data center. So we'll mention them all at least once. Reza will actually be taking notes. He'll give me a score later on how many times I said storage.
It won't be one.
It won't be enough. We'll talk about just general requirements for NSX, deployment considerations, then the case study, demo, and then questions. Although, questions. I'm curious. How many of you are familiar with NSX? So really, I got 4 hands. Okay. How many of you have NSX running in a lab, or you've done a POC, or you've got something like that? 1 or 2. Okay. All right. Good to know. I will spend more time on those slides at the beginning. All right. I joked with somebody yesterday that this is how I was going to do the whole presentation. I just give you those 5 topics on the top and just say questions, and we go the next 2 hours with just you asking questions. No? All right. See? Keep hoping that'll work. So why network function virtualization, or why software-defined networking? Part of the reason here, and I just stole this, even kept the VMware logo on it. So if you get a physical network, you're standing up a whole new environment. This looks pretty simple here, right? We got a couple of switches, we got a couple of routers, not too much going on here, and we're going to set it up. And then we start on the list of things we have to do. All right, so we've got, lags between the chassis, so we're going to take care of that stuff. We need to worry about the routing configuration, the SVIs, the router virtual interfaces, router redundancy, hot standby. Where are my network guys? That was another question. How many of you are network guys? Right, so this feels like old home, or the rest of you are going, HSRP, I don't care. SVI, isn't that just a port that I plug something into? Can't I just use that? Someone else takes care of that for me. Spanning tree. So we get all these things to do. Now, to be sure, when we do this with software-defined networking or with the NSX, this network function virtualization, we still have to do every one of these things, right? The spanning tree, depending on how we set it up, we may not need to worry about, depending on what we use, but we'll do those kinds of things. Then LACP, VLANs. Now, the VLANs is going to be kind of interesting. If you've had a VMware environment, so I'm most familiar with mostly because I've been out there so much recently. I'm most familiar with the environment at Department of Water Resources right now. So when we first set up their virtualized data center in 2009 and 2010, it was really kind of, it was an interesting exercise. All kinds of people feeling all kinds of uncomfortable about lots of different things. And we end up taking an approach that is a pretty common approach, and it's a good approach of just little building blocks, right? We figured out it was done with blade chassis. It was done with, Nexus 5K and 7K switches. We just figured out, all right, what's the configuration for a single blade? What's the configuration for a single chassis? What's the configuration for clusters across the chassis? What's the configuration for a single rack? What's the configuration? We just kept, and when it was time to scale it up, we just kept scaling it up. By the time we were done, we had 11 chassis deployed, and it worked out pretty well. Along the way, though, I know there was, oh my gosh, the network folks having a hard time with, as we're starting to do this little modular approach, here's some things we were given as requirements for this environment. Any virtual machine runs on any node in a cluster. The nodes in the cluster, because we needed to take care of high availability and the like, we're going to be spread across chassis, and in fact they're going to be spread across racks. And essentially what we ended up doing, makes sense to people now, hopefully 5 years later, is that any VLAN that was going to be needed for any virtual machine in that cluster was presented to every ESX host in that cluster. Hopefully that makes sense to you, right? So then we could pick up the port groups with the proper VLAN tags, we could put the machines where they belong, and we go forward with that. So in that process at Water, I think we ended up dealing with somewhere on the order of 25 or 30 VLANs. And then the real headache is, hey, we forgot one. Or we get a brilliant idea, we need a new one. Or we need 3 new ones because there's a new application come up, it needs to have its own thing. And so we have to configure the VLAN from the port group on the virtual machine, on the the virtual switch, all the way through. We had Cisco 3000 series I/O modules in the back of the chassis, so those are those are like a regular little Cisco switch, so that had to be configured. Then the 5Ks above that had to be configured, the 7Ks above that had to be configured, had to test it. We had different numbers on one side than on the other side to make the whole thing work. So to add a new VLAN took 7, 8 different places that we had to go do the configuration. Okay, it was better than what they had before, because at the very least they could just keep walking through doing it. But every time something like that had to happen, we had to go touch all those different things. With one of the striking things about doing this with NSX or something like NSX, we go configure this environment now, and we need basically the networks just to keep our vSphere environment alive. We need a network for vMotion, we need a network for management, we need a network for, maybe if we're doing IP storage, we need a network for IP storage, but we need more than one network for IP storage depending on what's going on. And we'll need a network, a VLAN, to be the transit for all of our encapsulated VXLAN traffic, should we choose to use VXLAN for this. And once we get past that part, it almost doesn't matter, right? If a new application comes up and the decision is to put it on its own set of networks, and we want those networks to be isolated, we don't have to worry about, or even if we want those networks to be available all over that data center, we don't have to worry about now going through and hitting every switch all up and down along the way to set up those tags. So this initial configuration, this is, we still have to do some of it. And then that recurring configuration, the things I'm talking about here. Now, and if you do access lists on the switches, okay, that was going on while we're doing that stuff. Taking care of the VLANs, taking care of the like. So lots of things to do, and of course the key for all of this to make that so it worked. So we had that environment where any virtual machine could run on any blade in any cluster in any rack on the row where that stuff was deployed. We had to make sure everything in that network environment was consistent. And of course we still need to do that right now. So here's where the network guys get to point out to the you guys call them server guys, system guys, I guess Spencer's in the room. So it was kind of nice, maybe before virtualization, depending on how you think about it. If for no other reason than the IT department's ability to stand up a new server had some pretty good barriers in place. We got to buy it, we got to find room for it, we got to make sure we got rack space, we got to make sure we got ports, we got all these things to do. And that tends to sort of meter the work that goes into bringing up new servers. Now, once we build that environment we talked about there with that whole virtualized compute infrastructure, now what's my impediment to putting up a new virtual machine? It's space, it's memory. I mean, there still are constraints. It's licensing, of course, because we still license operating systems and the like. But it's not that, well, they said they need a server. We know we've got 6 weeks before the server will even show up on a dock. And we know we don't even need to worry about that because it has to go through, somebody's got to receive it and somebody's got to do something else. And then we got to go negotiate with the power people on the white floor. I know you ordered a server, but that doesn't mean you get to put it in a rack and plug it in. Or worst case, I've seen it a customer, you can go ahead and put it in the rack. We're not about to let you plug that thing in. Okay. Or you're gonna have to trade me something. I'll let you plug that server in, but you're gonna find me 3 old ones to turn off, and then you can have that one plugged in. So before and after server, so before, basically had hundreds of servers at Water. I think they had somewhere 400, 500, 600 physical servers in that data center before we started to do the migration to the virtual. I changed VLAN on the switch port, okay, to control server connectivity, right? You can't use that VLAN here because we turned it off at the port, pretty straightforward. Features are dependent on the hardware functionality, okay? Complexity when configuring network services, and the traffic flow is mostly north to south, right? Think about that. It was almost always the one server up through that networking stack down to another server, right? And the amount of traffic that went server to server was a lot less in those days. All right, so after server virtualization, wrong button, sorry. So we just talked about it. A lot of those constraints are off. Thousands of virtual machines, yeah. You know, it doesn't take that much space to put up thousands of virtual machines now, if somebody's got a need for it and like. The VLAN trunk configurations, right, that was a big thing you had to worry about before. Previously, you had a single server plugged into a single port, so all you did was you configured the VLAN that server needed on that port. Man, the first time I had a meeting with somebody saying, this wasn't at Water, this was another customer. All right, we're gonna put in 6 new servers in this rack. We need 42 network drops. And they're like, 42? Yeah, we got 6 servers with, ILO, DRAC kind of access. And then they wanted to have redundancy for the different networks. So we're going to use not just one uplink, but 2. And we needed to do, vMotion. The management needed to be separated. And then we were going to do, because they were worried about the bandwidth for the virtual machines we were on the box, we were going to do 2 or 4 ports just for virtual machine traffic. Yeah. So first thing I get back from this person is 42 network drops in one cabinet. We don't put 42 network drops on a row normally around here. And the next part we got was, do you know what that means? We got to go buy a new blade for the switch that's in the next cabinet over, because we hadn't even thought about that stuff. Then we still had to negotiate power and the like, but and then we got 42 network drops, and then those four uplinks, those 4 ports that we're going to use for the virtual machines, what do we have to do? Trunk every VLAN that any virtual machine running in there might need. This is serious heartburn for network guys that are used to 1 VLAN per port. Having to consider, I got to put 5, I got to put 10, I got to put 20. Really? Do I really need that? Now, doesn't feel like such a big deal. Different teams manage different network components. So, how many of you have the switch folks? And then you have the router folks. Yeah. Yeah, server guys, yeah. And then you've got the patch panel folks, right? Separate from the switch folks, separate from and then we still have WAN folks, And there's still all that in there. And that's not even talking about the storage, server, those folks all together
That's
here.
3 times already.
3 times I said storage, all right. How much for you buying me a drink later?
Hey, you're wrong.
All right. Now, the other thing that we see is this traffic. Instead of this one server through that port on the switch up to somewhere else where it gets distributed someplace else, now we've got the capability here for these machines in this cabinet, these servers to talk to each other very easily. And as the virtual machine density goes up, right, that would be just like a lot more physical servers in your environment. So that's a lot more traffic, even just from the scale of it. All right, so I don't know that anybody need to be convinced that there was, like I said, networking is hard. Every network guy I've talked to for years has always told us that, right? Networking is hard. Can't force this on us. You can't make it do it. This is hard. We gotta figure this all out. So software-defined data center. So prior to this concept of a software-defined data center, we'd have hardware-defined, right? This was that before server virtualization there. We're dependent on the features being delivered by the physical devices, right? The ability to have a specific function on that piece of network hardware was dependent on the chips in that box, right? If it couldn't do a particular function and we needed that function, we have to replace the hardware, right? Go find something else that can do it for us. Dedicated vendor-specific infrastructure. Okay, now some people like this, some people don't. I mean, I mentioned the server management, right? So we'd have specific HP branded management, or we'd have specific Dell or IBM branded management. You'd have specific network vendor branded management for these things. And those things didn't necessarily go away, but we do have opportunities to do more from fewer consoles or have more integration with things. All right, now this software-defined, this is this approach that comes from, I guess familiar with Mark Andreessen, the guy that's founded Netscape, and he's part of the venture capital, the Andreessen Horowitz, and his main mantra is, just software eats everything. Eventually whatever used to be done in hardware will be translated into software, and at the point where it's translated into software, what happens to the hardware underneath? It's less and less relevant that it's from any particular brand, it's from any particular vendor. It just turns into a pool of capabilities. As long as we can meet those minimum capabilities, then we'll take care of the rest of it in software. And that's essentially the approach we're going to be talking about here, right? Our ability to simplify the management and the configuration of the infrastructure is based on that. We're really just looking for steady, stable, well-configured, well-maintained physical plant, and then the part that would be that recurring configuration, or that I need a specific feature to be presented to just specific machines in this environment, that happens in software, right? That happens logically, right? So this happened with the servers, starting 2001, 2002, and probably at this point, we're all well convinced of this. We buy servers for our virtual data center based on preference more than anything else, right? You can pick whatever brand you want. There's minimum requirements to run the environment. Pretty much any vendor, fancy name brand stuff, down to the white box people, can provide just about any requirement that's needed for running the hypervisors. So we don't need to worry about a specific brand having a specific capability for us. A little bit of that exists, but mostly it doesn't anymore. So we've just taken that compute capacity, we just turned it into a big old pool, right? We abstracted it away from the physical hardware. We think of it as a pool of compute resources, CPU, memory, the like. Storage people in the room? All right, so, so storage, it's happening whether the storage people want it to happen or not, right? The nature of the storage arrays is changing, right? How many of you still labor over exactly which disk goes in exactly which volume for presenting storage to somebody now? A lot of that just got taken away from you. The architecture of the arrays just turned it into, we're going to involve everything on this device, or we'll have a couple of tiers, they're well defined, and you'll use what's there. We don't go through that laborious, I need 3 drives for this and 1 hot spare, 4 for this, I need 7 for this, I need 14 for this. We don't do that anymore, right? And hopefully you don't miss that too much. I remember all these tables of all the drives and all the different colors, and then having to go back and figure out if it happened later. All right, so what happens there? We just make sure we get enough capacity to run those virtual machines. We make sure we get enough capacity with the right characteristics to provide that storage. Networking, we almost did that in that model I talked about at Water. So long as I had enough available bandwidth and I had the appropriate ports presented to the box, even the storage people, even the networking people figured out over time, they really had a lot less work to do on demand when a virtual machine was being deployed. Less work than they had to do previously when a physical server was deployed. Now, if we added a new ESX host, they definitely had all the demands they had before. Got to configure the ports, got to do all that stuff. That still doesn't go away. But we didn't have to worry about, hey, so-and-so in the GIS unit wants to run up a POC with 10 different servers for this new mapping and modeling software. If it used already existing VLANs that had already been presented into an environment, you didn't have to do anything for the initial provisioning. But there were still things farther back, right? We haven't talked about security, we haven't talked about firewalls, the like. And that's farther down the line, right? The firewall people, even after we had kind of alleviated this individual VLAN per VLAN configuration, still had to be involved, and it tended to be done just in time, right? So after the things are being deployed, after they start to come alive, then somebody's going to start to do that. So, but in general, the approach we took for the virtual environment can be applied to that network environment. Turn it into a big pool of capabilities, big pool of capacity, and then concentrate on the actual requirements in the software configuration, okay? So we got this already. So here's the NSX thing you've seen before. So here's your environment. We talked about this. We've got this network capacity. Right, if you see there, we've got physical switches in your environment. Those could be top of rack switches in your cabinets. They could be a combination of top of rack switches and maybe your if you've got a traditional, you got an aggregation layer above that, or it goes up to the core. And eventually, see, we've got access to the internet over there on the side here. All right, so then we've got our compute capacity, right? All of our ESX servers we've got in there. Could be physical servers. We're going to concentrate. Well, all of our ESX servers are physical servers, right? Isn't that one of the coolest things? Our whole virtual infrastructure is based on what? Physical. So the guys so what happens now? We used to talk about people being server huggers. They wouldn't give up their physical box to let it turn into a virtual machine. Pretty much what we did was we grew a whole new crop of server huggers. You know who those guys are? They have the greatest name. They're the virtualization administrators. Doesn't even say hardware in their name anymore, but they're the guys that are hanging onto the boxes. Well, if I don't have the same issues as before, well, I used to have 15 of these to take care of. If I'm only going to have 4, they're going to think I'm not doing work anymore. What's the problem? Well, that 4 carries more capacity than the 15 did before, maybe by a factor of 2 if it was enough time in between. So no worry there. So just laying out our environment. So we've got this data center virtualization layer. This is essentially our compute, right? So what did we do? We took those physical servers, we organized them into clusters, we organized those into resource pools that we could configure with different characteristics if we needed to, but in general, we tried to make them as consistent, as homogeneous as we could. Okay. And now, if we apply this idea, I take a a very well planned and well executed foundation on the network part, and I abstract the network functions away from this, from the individual pieces of hardware, treat them more as a, it's a pool of bandwidth, it's a pool of routing capability, it's a pool of switching capability. Then we can concentrate more on what we're trying to accomplish from the business standpoint than worried about configuring all the physical stuff repetitively. All right, so just like with our server virtualization, we had virtual machines. When we have this network virtualization, we now have virtual networks, logical networks. We've had virtual networks for a while now, right? It was that little piece that the traditional network guys feared that went between the virtual switch ports on the ESX hosts and the virtual machines they connected to. They were all freaked out. It was going to be a black box. It was going to do all kinds of incredible things. Hopefully your experience was the same. My experience always was. The server administrators weren't that interested in mucking around with those ports. And the network administrators weren't really all that interested in mucking around with those ports. So long as we followed a plan, it just worked, right? So we're going to take that to another level, right? The virtual networks we're talking about there had a direct correlation to a specific VLAN or a specific network in our physical environment. That's going to change, right? Once we start to really make that network segment logical and employ the tunneling, now we don't have that one-to-one with a network in the virtual space and a network in the physical space, right? I just have to have something to carry it in the physical space. Right, now, in my mind, one of the best uses for NSX is as part of a managed cloud or an automated infrastructure. When we talk about the case study with water a little bit later, that environment I described for you in 2009 was really nice and people appreciated it, but a virtual machine could now be deployed in about, I don't know, an hour. I mean, the actual virtual machine itself could have been deployed within 15 minutes or so, but if it needed some other things to be done manually, an hour. Let's be really, really generous. A day, okay? 5 days for a single virtual machine. That's before it got handed off to somebody else. And this is the part I'm trying to go to. At the point where it's ready to be handed off to somebody else, it took hour, half a day, a day. Now, that time from the point where that virtual machine was powered on, available, got an operating system, got an application, to when it gets handed over to the application administrator, the people that are actually going to run it, this is where that time is, right? Now, firewall rules, okay? Who are my network people again? How many of the network people think the people that ask for firewall requirements for the applications actually know what their applications do? Okay, so what happened?
No, we're just requesting ports of the networking people because in the documentation it said you need to have these ports open. I don't know why, but I'm just repeating what the book is saying.
So actually, I would, my experience, not so much as the network guy, but being in the room with these folks, the ones that actually show up and say the documentation says it requires this, they're ahead of the curve already. They gave the network people something to work with, not the, well, what's your application need? It's got a web front end. All right, so you need port 80. What else? Well, there's this database. Okay, so is it Oracle? Is it, and you play the 20 questions and it depended on you to recognize the ports and protocols and all that kind of stuff to make it work. No good. For no other reason than what? It just took so much time to go configure this stuff. Now, I've seen customers come up with a plan that says, all right, so here's what we're going to do. Here's how we're going to handle this. We're going to have zones, right? We're going to have these pre-configured environments. And we're going to say, if you put your web server in the web VLAN, we'll make sure that 443 and 80 are available to the outside. Or we'll make sure they're available to the outside through maybe some other device. We're going to have a reverse proxy or something like that. And we'll allow that zone to talk back to some application zone on some known ports. And we'll let that application zone talk back to our database zone on some known ports, 1521, 1433, whatever they happen to be. And we'll call it good. And that works right up until they wrote the application in the middle. They didn't buy the application in the middle, and they did something cool and interesting, and they don't know what ports it uses because it's whatever. Or ultimately, they just told you what. It uses RPC, and they were just going to force you to. So I just need you to open up everything, okay? Or the other part was it worked in testing where there were no firewall rules. I don't know why you guys broke it when we put it into production because it worked over there. Can't you just go see what it did? I know you guys got that. Can't you just go see what it did over there? All right. So if we make this part of an automated deployment and we get these things figured out in advance, we get these things made as part of the blueprint. So we know when you select this item out of the catalog, it's going to generate these machines, and they have this particular relationship, and we let all of that happen as part of the deployment. Now we have a machine that's going to be available. You said 5 days. I know 5 days was a goal for a long time to bring it in from longer than 5 days. All right, so I think it's animated. Oh, cool. It's all right. So what you didn't see was if we clicked the button, it was going to have somebody make a request for a 3-tiered application. They went in and said, I need 2 web servers. And so what got deployed out of it was 2 virtual machines on a web tier, 1 virtual machine on an app tier, 1 virtual machine on a database tier. The management environment, this one was VMware's Automation Center, or vRealize Automation, they call it now, had as part of the profile for that customer which networks those things would be delivered on. That was actually configured as part of the blueprint. Nobody had to go, the customer didn't have to ask, somebody else didn't have to go figure it out. It was pre-engineered, it was pre-configured, and somebody can spend the time to figure out what firewall ports actually need to be open and what they need to be open to. And they can do that ahead of time rather than waiting from that time between when the virtual machine got deployed to when the customer's waiting for it. Invest the time up front in the engineering effort for the blueprints, and then when we go to deploy them, they work. It's okay if it took 30 days to create the new blueprint. That was 30 days that's going to get amortized over every time we deploy something from that, right? It pays off. It's better than the, hey, I need another lamp stack, and it takes another 30 days to deploy a new lamp stack, right? All right, virtual network. We talked about this a little bit already, but the idea here, in our environment here, now we've got our hypervisor, we've got this NSX virtual switch. Now, in ESX, in vSphere, there's been virtual switches. We have a standard virtual switch, which is configured on each individual host. It's pretty much the maximum amount of interaction you'll have to have, the maximum amount of work. If we deployed 100 hosts, we have to go configure probably more than 100 virtual switches. For some years now, VMware's had a distributed virtual switch that can span multiple hosts. So what do we do now? We go configure that virtual switch for a group of servers, and when we add those hosts, those ESX servers, to that virtual switch, then they have the capability to provide access to those ports, provide access to those networks. NSX requires the distributed virtual switch. When they talk about the NSX vSwitch, that's the distributed virtual switch with some kernel modules on the ESX box, and we'll see that later. Now, that NSX virtual switch has the ability to do VXLAN. How many of you here are familiar with VXLAN? Okay, so we had 50 minutes for the first section, 50 minutes for the second section. We're gonna have a demo in there. We're not gonna do a packet walk. I'm not gonna pull apart a VXLAN packet and show you where all the bits are and how it all works. Here's the deal. VXLAN, think about this. I took an Ethernet frame and I put it inside another Ethernet frame. Right, so it's longer than the original Ethernet frame because I've got the source and destination headers, and I have the checksum, the information on the back. So another requirement we'll see there is you're going to increase the MTU in your network to allow for the new MAC addresses on the front. And a little bit. So for that encapsulation, pretty straightforward. Don't get too stressed out about it. That original Ethernet frame is just called data in the VXLAN encapsulated frame. The VXLAN encapsulated frame knows how to get it from one host to another. The NSX environment or your physical switches understand how this VXLAN tunnel works, and so they can actually encapsulate it where it's need to be encapsulated and strip it off and put it onto the wire when it doesn't need to be encapsulated. All right, so that's actually our virtual network. So the virtual network here exists in this, they show this container. Now, that container, we're gonna add some services. So we've got a virtual network logical switch, okay? In NSX terminology, a logical switch is a virtual network, all right? We also can have a logical router, okay? So previously, what would happen? I got two virtual machines on the same ESX host. It's that application we just deployed there, two web servers, one app server, one database server. They're all sitting on the same host. If I've got my traditional networking environment, what has to happen? When the app server wants to talk to the database server, the frame from the app server has to leave that ESX host, go up through my switch infrastructure, then be directed back down, up to the switches, down to the routers, and then back down to the appropriate thing. Now, could be that virtual machine is on the very same host, but we don't have any way to route that traffic on that host. We had to leave the host, go out through our physical environment, and come back in. With the distributed logical router, we can handle that kind of routing right on the ESX host itself. So we can save bandwidth on the environment. Okay. There's other network services here. There's also the firewall, okay, the distributed firewall. Something to point out about the distributed firewall, we don't have to have VXLAN at all for the distributed firewall to work in your environment. In fact, if you just wanted, I know micro-segmentation was in the abstract because anytime somebody says NSX, they always say micro-segmentation at the same time. So micro-segmentation is really pretty simple. I've got machines that share the same network. Okay, let's put it plainly. They all sit on the same VLAN. And without heroic effort, I can simply make it so that machines on that same VLAN don't talk to each other. I don't have to put up, how many of you do private VLANs? How many of you configure private VLANs in your environment, right? This was the way you could do it. I got a whole bunch of web servers. They're all in my web VLAN, but somebody told me it's not a good idea to let all my web servers talk to all my other web servers. So I tried to come up with a way that I could still use one primary VLAN for my web traffic, my presentation layer, but I want to be able to pick and choose which one can talk to each other. Sound familiar?
Yeah.
So I got one hand that got raised. And that's generally what I find. I've gone into network folks and said, okay, so private VLANs? And they just go, no, we don't want to do it. We'd rather burn more VLANs to do that another way than to have to deal with private VLANs. Okay? This is super simple, really, and the amount of effort that goes into this really is I don't want to say trivial. Nothing's trivial when we're starting to do this stuff, but the amount of effort is low. It's very straightforward to do this. All right. Then also we could have a virtual load balancer. That's all part of the NSX environment here. So here I've got two virtual machines on the same network. Now, honestly, we could have done this with the traditional vSwitch. This always worked, two machines on the same port group. The VM kernel is smart enough to just go ahead and pass those frames between the machines. Okay. Where it got fun was two machines on two different networks, and that's what we were talking about here. And in this case, we can use the, if I need to go to another host and it's on another network, that's fine. We just do the normal switching thing. We don't have any choice if the machine's on another host, it's gonna have to run across our physical fabric. Programmatically provisioned, that's back to this automation example. We'll see more of that in the demo. And the cluster controller, again, just more of what goes into NSX here. The cluster controllers are important. They have essentially the view of this entire environment. They're actually what keeps the MAC tables. They're actually what keeps the ARP tables. They actually keep track of the endpoints for the virtual tunnels. And they distribute that information to the ESX hosts that participate based on what's actually deployed on that ESX host. You know, if a virtual machine's not on that host that uses a particular VXLAN tunnel, the host won't know about that tunnel until something, you know, causes it to need it. The MAC tables, again, those are distributed that way. We don't have a lot of just ARPs going on here. It's being suppressed by the controllers taking care of most of that. The VMware switch knows those MAC addresses. When the virtual machines get powered on, those populate the tables, and that gets propagated across the hosts. We don't have to wait for them all to learn it on their own. All right, so there's our programming. Services distributed to the virtual switch. So now they're going to talk about the, here's the actual flow. Right, so those two machines, logically they're on the same network. Physically they're on two different hosts. We have to use the physical network to move the packets from one host to another. No magic there, nothing really new. The virtual switch can do quality of service marking, and that will be understood by the underlying switches, assuming what? They have that capability. Right, it had to be in the software. Native isolation, right? We don't share the traffic. This never worked, by the way. Even the traditional VMware vSwitch, two virtual machines on two different networks. We didn't occasionally, just for the heck of it, bleed traffic over between one virtual machine and another. It's always been isolated. That follows through here.
So, sorry.
Go ahead.
So, in your physical switches on your diagram, are they required to be layer 3 switches? And since technically switches are still just layer 2, I mean, or are they going to require to bounce off the core switch, or are they going to do that within your virtual? Are they going to reroute within your virtual switch before they hit the physical network?
So so we'll talk about deployment considerations.
Right.
From VMware's recommendation here, the deployment guideline would be have that physical network, have it set up as a leaf and spine, top of rack switches to some aggregation switches, the spine switches, and have that layer 3 between the leaf switches and the spine switches. Or it can be done with, only because there's Brocade people in the room and we use this in a couple of implementations I've done. Rather than do that, you can use their VCS fabric, right? But that takes care of that communication between the switches. All right. So data center security, I stepped on this a little bit already. We're doing all right. So I don't mean to keep picking on water, but it's the one I'm most familiar with. And now Tony's left the room, but Mark's still here. Tony left the room. So when that first virtual data center was being put together, there was this elaborate security design put together with Cisco Advanced Services. It really did involve upwards of 30 different security zones. And it ends up with, you know, all of these different firewall configurations to go between all these different zones. And an actual implementation, I think it did more to expand the amount of work that had to be done than it did to simplify it. So the goal was not to be forced into trusting the individual servers that made up an application, not being forced into just letting them all talk to each other because they're part of the application. But in actual implementation, it's a lot of work to go configure all those firewall rules for all of those components that made up those applications and all the different places they could show up. So kind of the idea here was lots of places, not so much lately, but before, right? Security from a firewall standpoint was really at the perimeter. If it's inside, it's inside. We're trying to keep the outside from the inside. That's it. Or they try to do more on the inside. It's just really hard to do. Now, could be done. People certainly could do it. In my opinion, the main missing piece there was a way to manage all those firewalls as a more cohesive entity. Actually go through and have something that understood, here's what I'm trying to do with these zones. and configure the rules and have it applied. All right, so now, with the approach we've got here, and the biggest thing we've got going now is when we deploy NSX in the environment, and this is the simplest deployment possible, right? If all I want to do is micro-segmentation in your environment, I install the NSX Manager. It's a virtual appliance. The NSX Manager gets registered with your virtual center. And we use the NSX Manager through a plug-in to the vSphere client to prepare the hosts where I want to run virtual machines that are going to use the NSX services, right? So when we prepare those hosts, the NSX Manager has kernel modules installed onto the ESXi hosts. There's a module for the distributed firewall. There's a module for the control plane for NSX. It's got a really fancy name, Network Control Plane Agent, NetCPA. And then there's a piece that allows for the distributed routing. And that's pretty much it, right? So we can do firewall. It already could do the switching because of the vSwitch. We're basically taking advantage of the distributed virtual switch. We added the firewall, we added the routing, and that's what we need. At that point, I could do micro-segmentation. I could go through and deploy a distributed firewall. I could create rules. And the thing with the distributed firewall, when we start to use this in actual practice, it'll work with the traditional 5-tuple, right? Everyone's used to this 5-tuple rules. It also works with objects from that VMware environment. It also works with security groups that you can define. It also works with security tags, attributes of these machines that can be provided by you directly, can be provided programmatically, through an automation system or through third-party integrations. Right? An example of that might be Trend Micro or somebody else that's doing anti-malware scanning. If they find a machine has malware on it, they can go through and tag the virtual machine in a way that's going to force it to go into a different security group where we could, prevent it from talking to any other machines on the network, or we could put it into a place where it's going to get deeper inspection. We're going to put it on a network where we've got very aggressive intrusion detection running or something like that, so we can get a better idea what's going on. That can all be done programmatically. This doesn't require VXLAN. This doesn't require any modifications to your physical switches at all. This could be done just in place. All right, so the firewall is distributed in the kernel. Now, we'll go through the slides here. That's the traditional. Come on. Now we've got the firewall right at the virtual machine. Okay, and if that virtual machine moves, that firewall configuring went with the virtual machine. Actually, the firewall is implemented, the distributed firewall is implemented at the interface between the virtual NIC on the virtual machine and the VM kernel itself. So that frame, it's just like you had a host-based firewall on the virtual machine. That frame would be dropped before it actually got out of the virtual NIC. Okay? And you didn't have to go configure the virtual machine specifically. I didn't have to go to the operating system in the virtual machine to configure it. I didn't have to do something else. I can do it all externally. All right. So now, physical firewalls, virtual firewalls. I put this in here because this is ongoing contention, an ongoing debate here. One of the main features of NSX is the distributed nature of these network functions, right? We didn't concentrate the firewalling function in the biggest, meanest, baddest firewall you ever saw and its brother, right, that we carefully configured to have them work together. You probably still have that in your environment, right? Between the internet and your inside environment, you still have that. But we don't need to worry about, well, you still need to worry about bandwidth, but here's the deal. Every ESX host that has distributed firewall deployed has bandwidth for the virtual machines that are on that box. The more ESX hosts I have in my environment, the more bandwidth I have available for the distributed firewall, right? It scales with the hosts. Okay, so that's hard to get used to for some folks. People on teams are working on. First question, right? If you're a firewall guy, if you're a network guy, what do you want to know? What are the things you want to know about firewalls from a performance standpoint? What was that? I was going to say that. What's the bandwidth and how many sessions can I have? All right. So he sells firewalls.
Oh, a softball.
That's all right. They're all supposed to be softballs. This wasn't supposed to be a test. This was supposed to be a,
Oh, there's a test.
so distributed. Same thing goes with the routing, right? That routing throughput is also distributed across the host and the environment. It doesn't have to be concentrated into big boxes, right? So I think we put in a slide here from VMware's testing, which should say VMware having someone else test it and report back. Distributed firewall, they say they get 20 gigs per host firewall performance. The dark blue is with no filtering. The light blue is with filtering. From VMware's perspective, this isn't putting a heavy burden on the VM kernel either. This isn't chewing up all the CPU. This isn't taking up everything else. So if you need to think about this, if I have an 8-node cluster, which at this point, I don't know, how many of you have clusters that are more than 8 nodes? More than 16? More than 32? 64, anybody? Just to see if 64 would.
Cluster?
Per cluster, one ESX host, you can have up to 64 hosts in the cluster.
Oh, I have 6 to 8 ESX.
All right.
I have many more.
There you go. So if I've got 8 hosts times 20 gigs per host, that's a lot of bandwidth for the firewalls for the virtual machines on those hosts, right? So, and if we're worried about the distributed firewall, if we're worried about that load, what you would end up doing is add more hosts to the cluster, spread out the virtual machines across the cluster. Hopefully, if you're familiar with virtual infrastructure, that feels right. One of the lessons that people learned over time with the virtual infrastructure was scale out is probably a better model than scale up. Don't build 2 really big ESX boxes and put everything on those 2 boxes. Build more relatively smaller boxes and spread it around. You generally end up with better capability to do maintenance, better capability to do other things. So for that, if you applied that here, or you may inherit that, right? You already have enough ESX hosts that firewall throughput is not going to be the bottleneck. So here's the performance. This was sessions, because just like Chris said, the other thing they want to know about is the sessions. So depending on the number of rules, the sessions go down. We're still at 300 to 400K connections per second per appliance. 80 connections per second with 100 rules per host. 80K connections off of a single ESX box. Think about the virtual machines you run on that box. The idea is that's enough scale for an individual host. And we deploy these in clusters, so we've got more than that anyway. All right, where are we? We're 11. I think I'm just going to go a couple more, if that's all right, and then we'll take a break. At least 5 minutes for the break. So the platforms, these native capabilities here, we saw when we deployed it, we have the distributed firewall is deployed in the box, the distributed router is deployed in the box. We've got that security capability right in the VM kernel. Any virtual machine running on that host could have firewall rules applied to it right at the VM NIC level, right at the virtual machine NIC level. Okay. The biggest difference I see from this versus the example before, remember the circle with all the firewalls in the middle of it, is that we configure these distributed firewalls logically as one firewall. Right? We think about the virtual machines running in our environment as the servers in our environment. We configure the firewalls to manage the traffic that's going between those servers and the environment. And then we let NSX, through the NSX manager, distribute those firewall rules across all the nodes in the cluster. So if I've got 100 ESX servers in my environment, I don't have to manage 100 different firewalls. I manage one firewall that's distributed across those 100 hosts. Okay, that's a, from the scalability or that ability to actually operate it, that's a key capability. The example we saw before, you end up managing all the individual firewalls probably as one-offs. Okay. We've talked about the automation, the provisioning. Don't lose sight of that. The virtual machines, and this isn't even with using something like the Automation Center or using some kind of a cloud management platform. This is just simply the rules are tied to the virtual machines, and when the virtual machine moves from one host to another, the rules go with it, right? Because they're being programmed on the host. I think all we got here is this would just try to point out here. Here's our web application database. We've got our virtual machines here. We deploy them in our environment. Because the firewalls are configured per machine, in his case, we're showing they might have some service redirection out to trend. The key thing here is that configuration goes with the virtual machine. So if you need to do maintenance, or if you use the regular load balancing that VMware uses, the DRS load balancing, and that virtual machine moves from one host to another, whatever policy applied to that virtual machine as far as firewalls just moves with that virtual machine from host to host. Okay. So I think that's what we see here is that they move. Yeah, what if it moves to the other one? It just moves with it.